Today, I'm going to walk through the three major pieces of evidence that are often discussed when people talk about climate change. The first piece of evidence is that carbon dioxide acts as a greenhouse gas and humans increase CO2 in the atmosphere. The second piece of evidence is climate models. And the third piece of evidence is the idea that 97% of scientists agree with the consensus view. For the first piece of evidence, let's start with CO2 being a greenhouse gas. Most scientists agree that CO2 is a greenhouse gas, meaning it helps trap heat in the atmosphere. This idea comes from basic physics. CO2 molecules absorb and re-emit radiation, which prevents heat escaping into space. Without greenhouse gases, scientists agree that Earth would be cooler and would not be able to support life as we know it. There's also a strong pattern in historical climate data showing that when CO2 levels rise, global temperatures tend to rise as well. Ice core examples, for example, show that over long periods of time, CO2 and temperature quite often move together. On top of that, human activity has significantly increased CO2 levels, especially since the beginning of the Industrial Revolution. Burning fossil fuels like coal, oil, and natural gas releases large amounts of CO2 into the atmosphere. This led to a noticeable increase compared to the pre-industrial levels of CO2. Because of this, many scientists conclude that humans are playing a major role in climate change. However, the minority would disagree with a lot of those points. One of the biggest points that the minority would disagree with is the idea that correlation equals causation. The minority would state that correlation does not equal causation and would argue that just because CO2 and temperature change together doesn't necessarily mean one causes the other. Critics point out that in some historical cases, temperature increases actually came before increases in CO2, which suggests that other factors could be driving the changes. Another argument is that CO2 makes up only a small percentage of the atmosphere, less than 1% to be exact. Because of that, some people question how something so small present in the atmosphere could have such a large impact on our global temperatures. There are also natural factors to consider, like volcanic activity, solar radiation, and ocean cycles, all of which can influence the climate. Critics argue that these factors might play a bigger role than is sometimes emphasized in the mass media. So, overall, the disagreement here between the two sides isn't really about CO2 or whether it can trap heat. The argument is about how much and how important it is compared to everything else that affects the climate. Now, for evidence 2, climate models, the consensus would say that climate models are basically advanced computer simulations that scientists use to study how Earth's climate works and predict future changes. These models take into account things like temperature, atmospheric gases, ocean currents, and energy from the sun. The main scientific view is that these models are based on well-established scientific principles and are consistently being tested and improved. Consensus scientists compare model predictions with the real-world data, and when models don't match observations, the scientists can simply adjust them to improve accuracy. Over time, this process has made models increasingly more accurate. Many scientists argue that climate models are especially good at predicting long-term trends, even if they aren't perfect in the short term. For example, they can give a general idea of whether temperatures will rise, fall, or stay the same over decades. However, the consensus argument fails to understand that there are many criticisms of climate models that the minority would give. One concern that the minority would give is that they don't always match real-world observations exactly. Critics argue that if models were truly accurate, they should consistently align with measured data. Another issue is that models rely on assumptions. Because the climate is so complex, scientists have to estimate certain variables, and critics say that this can introduce lots of uncertainty. The term fudge factors is also used among minority scientists, and that is when sometimes people use data to describe adjustments made to make models fit expected outcomes instead of what the models would actually result in. Minority critics also argue that models tend to overestimate warming, predicting higher temperatures than what is later observed. In addition, there are concerns about funding, with some suggesting that the government support for climate research heavily influences the direction or interpretation of the consensus modeling results. All of this points to a bigger idea of which models are tools and they are not perfect representations of reality. They're useful, but they can depend heavily on the data and assumptions that the scientists build into them. And lastly, for the third piece of evidence, the idea that the 97% of scientists agree with the consensus is another main driving debate that the scientists use when discussing climate change. The main argument here is that there's overwhelming agreement among experts that climate change is happening and that human activity is a major cause. This conclusion comes from peer-reviewed studies, scientific organizations, and international reports. Supporters say that when many experts agree, it usually reflects a strong and consistent body of evidence. The consensus would also point out that often included in this argument is that these scientists are specialists in climate science, meaning that these scientists have background and expertise to allow them to experience and evaluate the data in depth. The research supporting the consensus is also peer-reviewed, meaning other experts in the field have examined it before it's published. On top of that, many governments and international organizations rely on this consensus when making policy decisions, which shows how widely accepted it is as an international level. But there are also criticisms of this claim. Many minority scientists would argue that the 97% number is very misleading and is based on selective data and specific definitions of agreement. Others point out that science isn't determined by majority vote. Just because most scientists agree doesn't automatically make something true. Minority criticism also includes that the consensus can change over time. Throughout history, there have been cases where widely accepted scientific ideas were later revised, like eugenics, or replaced as new evidence emerged. Because of that, some people argue that focusing too much on consensus can actually discourage questioning and slow down scientific process. So while the consensus can be useful for understanding where the scientific community stands, it's not the only thing that matters when evaluating a claim. One piece of evidence, bigger picture evidence, alongside data, methods, and ongoing research. To wrap things up, these three areas, CO2, climate models, and scientific consensus, show how complex scientific discussions can be, and the same pieces of evidence can be interpreted in different ways depending on assumptions, methods, and perspectives.